Okay, continuing on with the idea of quadratics, number 7 is a quadratic trinomial. So I'm going to check to see if I can factor it. If I can find factors that multiply to the outside, so the quadratic term and the constant term, 3 and -4, use their coefficients. If I can find two numbers that multiply to -12 and add to 1, which is the linear term, then it can be factored. Since -3 and +4 would work for both the multiplication and the addition here, that means I can factor it. Now remember, every algebra teacher has their own system of how to factor. I factor by splitting the middle term, then grouping in pairs. Okay, so GCF of the first two is 3x, GCF of the second two is 4. Put the GCFs in the first binomial. Divide the first two terms or the second two terms, because you get the same answer, by the GCF that you found for each pair. And you have your factored form. Set each one equal to 0, and that gives you your two solutions. 1 and -4/3. Show as much work as you think you need. You don't actually have to show all the steps when you're solving your binomials. Okay. If you look at number 8, there are terms on both sides of the equal sign. Since there is a linear term, I'm going to try to factor this, but before I can do that, I need to move everything to one side. I tend to look for the quadratic term. If there are two quadratic terms, so if there's a quadratic term on the left side and the right side, I move the smaller one. I like to make sure that my quadratic term is positive. So since I only have one quadratic term, I'm going to go ahead and leave it on the left side and move everything else to its respective partner. So this 2x, I'm going to subtract it, cancel it from the right side, move it to the other side. I'm also going to go ahead and cancel the 4. Now notice my goal here is to keep things with their like terms, right? So when I move the 2x, I canceled it with the 15x. When I move the 4, I canceled it with the -2. I combined it with the -2. Your goal here is to get your quadratic, your linear, and your constant term on one side. As soon as you have the 0, you can go ahead and factor if possible. So for this one, I'm going to try to find two numbers that multiply to -30 and add to 13. Be careful, because you might think, oh, 3 and 10 would work. But nope, it's actually -2 and 15. No combination of 3 and 10, no matter where you put the negatives, is going to work for both the multiplication and the addition. Remember, it's crucial that the two factors you find multiply to the outside product, so 5 times -6 is -30, and add to the linear term, which is 13. Okay. Factor this the same way that I factored previously. If you're going to be using my strategy, feel free to factor this a different way. It's up to you how you want to do it. If you don't know how to factor, I suggest you watch Khan Academy videos or use other resources, because it's super, super important for you guys to know how to factor. You're not going to survive the rest of the year. Okay, set each one equal to 0, and your solutions will be -3 and 2/5. Again, number 9. If you have a linear term, so there's that linear term, if you have a linear term, your goal is to send all your terms to one side and obtain a 0 on the other. This one has a quadratic term on both sides. I tend to move the smaller one, so -1 has a lesser value than +3. So I'm going to move this one over to the other side. And I'm not going to stop until I obtain a 0. Once you've got a 0, you can try to factor the trinomial. Here I'm looking for two numbers that multiply to 8 but add to 9. So that's 1 and 8. GCF of the first two, GCF of the second two. So the GCFs respectively go together. And then the remainders of the division of the first two terms by x, or dividing these second two terms by 2, they're going to give you the same thing, is 4x plus 1. So your two solutions are -2 and -1/4. If you still need to show your work for how I got -1/4 by setting it equal to 0, subtracting the 1, dividing by 4, go ahead and do so. But you don't have to if you already know what the answer is going to be. Okay. The next one has a linear term. I told you at the beginning of the first video I made that whenever there's a linear term, I'm going to try to factor. So this is a binomial. I'm going to check to see if there's a GCF. They both have an x to the first power, so I'm going to factor that out. That would leave me with 3x minus root 3. Once you've got linear terms, you're going to set each one equal to 0. Well, x equals 0 is one solution. The other one you might have to show your work for. Cancel addition and subtraction first. Cancel multiplication or division. There's no root, or sorry, I didn't have to square root the x because there was no exponent of 2. So the solutions are 0 and root 3 over 3. Remember what I said, whenever I see a linear term or x to the first power, you want all those terms to be on the same side of the quadratic term and obtain a 0. It's super, super important that you guys understand that in order to solve a quadratic that has a linear term, you need to make sure all your terms are on one side of the equal sign. Now, I hope that you guys notice that the x in number 10 is outside of the root, and the x is outside of the root for number 11 as well. So the root is only on the 2. It's like a coefficient. This is a binomial. I notice that they both have x to the first power, so I'm going to take that out as a GCF. That leaves me with 5x minus root 2. Then you solve it similarly to the other problem that we just did. Set each linear factor equal to 0, add the root 2, divide by 5, and those are your two solutions, 0 and root 2 over 5. Remember, you can always pause the video, rewind, work at your own pace. Now, this whole review was supposed to be reviewing how to solve quadratic equations, but number 12 is not a quadratic at first sight. It's a cubic. However, if you look, there's a GCF of x to the first power. And if I factor that out, I'm left with a quadratic. Now, this is a linear factor, so I'm ready to set that equal to 0. Quadratic factors, you can set it equal to 0 also, but this one has two methods that you can use, method 1 and method 2. This is a difference of squares. So you can factor it as x plus 2 and x minus 2. And obtain solutions of negative 2 and positive 2. So method 1 is you could factor. It's a difference of squares. Method 2 that I talked about in my first video is that if your quadratic does not have a linear term, you can use SADMAP. So you could factor using difference of squares, or you can use SADMAP if there's no linear term. And square root. Either way, this problem, because it was a cubic, can have up to 3 answers, and we did have 3. Our answers were negative 2, 0, and 2. The 0 came from the linear factor that we factored out at the beginning, and the negative 2 and positive 2 you can get from factoring or from using SADMAP. All right, guys, please send me a message through Remind if you need extra help. Good luck!